you collecting the
I'll get them at the end, since we already started this. Let's see. Okay, so let's go ahead with this. Again, it's more of the solving equations with variables on both sides, but we kind of focused on the easier ones. So here's a word problem, right? When I do the word problem, it's usually not with a you try afterwards, but there'll be a homework problem, so you need to kind of refer to what we did in class. Right? A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. Right? The number of used cars sold has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? Well, first of all, are there more new or used cars? They said at the beginning there's more new. Okay. The number of new cars sold, though, has been increasing by, what happened there? Has been increasing by 6 cars per year. Okay. Okay. So how do I write the expression for the number of new cars? It's started at, what is it starting at? 78. Erase. Blue. Okay, so it starts at 78, and then how is it changing every year? It says it is increasing by 6 cars per year. So how do I write that? Plus 6 times a variable which we could call y is the number of years. So 6y. Okay, how can I write the expression for the number of used cars? It's starting at 67, and it's losing 4 per year, minus 4y. Okay, so those expressions would represent for any one year how many they've got. Okay, now they want to know, when will the number of new cars sold be twice the number of used cars sold? Right, so how could I make an equation out of this? When will what be equal? Number of new cars equals twice the used cars. How do I write twice the number of used cars? Wouldn't it be 2 times 67 minus 4y? So that what they're really asking here is, when are those two going to be equal? Because after that, then there'll always be more than double the number of new cars than used cars. So we've set up what looks like an equation with variables on both sides. How do I solve it? Distribute first. Okay, 78 plus 6y equals 2 times 67. Calculators, come on. Say again. 134. And then minus 2 times 4y. Okay. Okay, now if you're going to follow my recommendation, what's the next term you're going to try to cancel on one side? Which one? Which is less? Positive 6 or minus 8? Negative 8 is less than 6y. So how do I cancel a minus 8y on one side? Add them. Add 8y. So it's going to be 78 plus 6y plus 8y, 14y, and 134. Okay, so now it's a 2-step equation. So we are going to, as Adam just said, we're going to subtract 78. Oh, here we go. Okay, so minus 78. So somebody with their calculator, tell me, what is 134 minus 78? 56, that sounds right. Okay, last step. Divide by 14. Say, what is 56 divided by 14? 4. So, okay, what does that number 4 represent? How many years it took so that new car sales were exactly double the used car sales. And if they keep on their trend, it'll always be more than double. You know, we'll do the same problem when we get to inequalities, and then we'll solve it like an inequality. Okay. So now here's the one twist in solving these equations that we've got to be ready for. And these come up from now on in this class. You can get this kind of problem, and you're supposed to know what to do with it. And it continues for all the math classes from now on. What would you say is the first step here? Distribute, right? So I do 3x equals 3x plus 12. Okay? Subtract 3x from both sides. What do you get on the left-hand side? 3x minus 3x.
0.
You get 0, right? Anything minus itself is 0. So that is just a 0. Believe me, that's the one place you guys make a lot of mistakes on this, because you don't want to believe that it's just 0. So somehow you'll put an x or something, but it's 0, really. 3x minus 3x cancels each other out. Okay, on the right-hand side, what do you get? Just the 12, okay? So notice what happened. When we subtracted a variable term from one side, it actually canceled the variable terms on both sides. Now, usually, we're solving this to find the value of the variable. But at this point, we have an equation that doesn't have a variable. What that means is the answer doesn't depend on the variable. It's either always true or always false. So look at this statement now that we got. 0 equals 12. Is that true or false? It's false. So when you do this, when you cancel all the variables in one step and you're left with a false statement, right, then you say, therefore, no solution. There's nothing that you could have plugged in for x in that original equation that would have made that come out. So you got to be on the lookout for problems like this, that you could end up getting a no solution. Okay, let's try this one. Again, first step, distribute. Now we get 2x plus 10 equals 2x plus 10. And again, I could subtract the variable terms from both sides, and what am I going to get?
0.
I get a statement. I got 10. The 2x cancels the 2x, but there's still a 10 left on both sides. So again, because there's no variable, it means the answer doesn't depend on the variable anymore. It's either always true or never true. In this case, does 10 equal 10?
Yeah.
Yes. So then you're going to say that is true. So the solution, actually, you could say it in two ways. You could say the solution is all real numbers and the other thing you could say is that that means that this statement right here is what they call identity. It's an identity when that kind of thing happens. Identity. And they'll use those words. I mean, in the end, that equation was really just a textbook example of the distributive property, right? We could have said that was true just saying, according to the distributive property, that's true. It's done. And then another thing to note, remember I was telling you that sometimes if you've got a variable on the right, that sometimes you might want to like switch it around and put it on the left. And that's got a name. That's called symmetric property. But when you get down to this kind of thing here, and you really are asking yourself at the end, does 10 equal 10? And that's like obvious. Of course it equals 10. But that actually is a property. That's called reflexive property. So if you were doing in pure math terms, you would say, yes, by the reflexive property, 10 equals 10. And that's a question you could get asked on the SOL. I wouldn't ask it, but it's one of the properties. Okay, so try to solve that one. And notice that it says, if possible. The directions say, if possible. It's kind of leading you to the idea that, you know what, it may be one of those that is either No solution or identity. So go ahead and try that. So what did you say about this one?
6 equals 6.
Okay, but 6 equals 6 is a statement, right? What does that tell you about the solutions here? It's true, which means it's an identity. It's either all real numbers or it's identity. If you get to the point where you say 6 equals 6 and you don't go on to say that means it's an identity, you're going to lose major points. Because that's the whole point of that kind of question, to get you to realize that. Right? So, and both sides you had to distribute. 6a plus 6 equals 6a plus 6. I mean, at that point, you know what's going to happen because it's the same thing. I mean, you could use reflexive property now and just say, you know, of course, that's true, right? If I subtract 6a, then it says 6 equals 6. 6 equals 6, right? Which is true, therefore, identity. It means you could plug in anything you want. It was always going to be equal on both sides. Okay, try this one. What was the first step? Subtract 7w, okay? You know, you get careless and just say 7, but then on your paper sometimes that's what you do. You end up actually subtracting 7, not 7w, and then of course it leads to a wrong answer. So you need to be a little more attention to detail. Minus 7w, minus 7w. So the 7w's cancel, now I've got 1 equals 8w minus 7w is 1w, which I just write like a w, plus 1. Then what? The w is not isolated, so I have to subtract 1 from both sides. So on the left I get 1 minus 1 is 0 equals w. What does that tell you? No. That's fine. W equals 0. That's an answer. 0 is a number. That's the answer. Don't not believe it because you get 0, because it happens a lot that we just like don't want to understand what it's telling us. I mean, how could I check it to make sure that it's true? Yeah, I mean, if you're doubtful, then plug it in here, right? Then you would get 7 times 0 plus 1 equals 8 times 0 plus 1. And what is anything times 0? 0. So then you get the 1 equals 1. Check. That was the right answer. Okay, one more, and then we're done. All right, try that one. So what did you say? No solution. In the end, the answer is no solution. Right? So we're going to get 9z plus 12 equals 9z plus 27. Subtract 9z. 12 equals 27, which is false. So we say no solution. Okay. That's it. So, homework.